highly targeted and exactly what you want to see. So that's what we're going for. It'll definitely be container related. So
Bingo.
uh, that said, what should we talk about today, Adam?
Well, I mean, so first of all, like, let's talk about what we did over the past 2 days because I think we did quite a bit. Um, and so Brent, you want to take us through what we've done and maybe what's coming today?
Absolutely. Yeah. So we did do a lot. It feels like a lot, but there's even more to talk about. So we started off Monday. We talked our way through the intro portion of EKSWorkshop.com. And if you're new to the stream today, you weren't here on Monday, then maybe you want to get caught up. So we just went through the introduction section and kind of talked about the mechanics of Kubernetes and what EKS does to make using Kubernetes easier when you're in AWS. So definitely, go through that. Ask any questions in the chat that come up. We're always happy to answer those. You can tweet at us, and we'll definitely answer back. So feel free to try and get caught up by any of those ways. Um, Tuesday, we began the workshop by launching our cluster using EKS control. So you can, again, catch yourself up if you weren't here on Tuesday by just following these workshop instructions. Then yesterday, wait, I'm confused. Did we launch an app yesterday?
We didn't launch just. Well, I mean, we launched three apps.
That's right. Okay, so yesterday we also deployed the dashboard and deployed our example microservices. So that's why it seems like we did a lot, because we did. Um, so today, what we want to talk about is sort of parameterizing those deployments. So we're going to yesterday we cleaned up our applications. They're no longer running in the cluster. Today we're going to relaunch them, but we're going to do it using a mechanism called Helm. And so we're going to talk about Helm, what it is, when you would use it, and then we're gonna use it. So yeah, so that's what we're going to aim for getting through today. And by the end, again, if you have any questions, throw them in the chat. As we're waiting on stuff to happen, we'll check out the chat and we'll try and answer the questions.
And there is a question that came in already,
Oh, sweet.
which we probably need a little more um, elaboration on. But how is this different than AWS libraries like AWS Rails Provisioner Library?
Well, okay, so what we're talking about isn't necessarily a library or anything like that, although we have actually, in the past couple days, talked about a few different AWS incorporations. Uh, so, what we're talking about is an AWS service called EKS. And EKS is, we want it to be, and we think it is, the best way to run Kubernetes on AWS. So, with the EKS service, we're actually managing the Kubernetes control plane for you so that you don't have to worry about all of that. I think one really cool demonstration that we might try and do maybe on Friday or something is let's just go through a Kubernetes upgrade because that's something that is well, it's harrowing if you're doing it on your own cluster, on a DIY cluster. But instead, if we're doing it, on EKS, it's pretty easy. So we can walk through that process. Let's just put that on the calendar for Friday, and we could talk about then, further solidify how using EKS is really, really advantageous for you. As far as libraries and stuff goes, we've talked about and mentioned CDK. We've mentioned CDKs for generating application YAML. And we've talked about EKS control for building the cluster itself. It's not a library per se, but it's a command line utility. So it's different than the AWS libraries because it's not an AWS library. Does that answer the question?
I think so. And I'm looking at, I just, while you were talking, I did a little Google search and I see the AWS Rails provisioner. So this is AWS Labs GitHub organization, and it looks like it actually is a way to provision your containers to run um, in AWS. It looks like it wraps around CDK. So,
Interesting.
and reading it, it actually looks like it works with ECS. So I'm not sure if there's EKS support. Just to be frank, and I think it's pretty obvious, I'm not super familiar with this um, tool, but maybe we can talk about, I guess, how, because I know we're on the context of Helm right now, so I don't know, maybe how would something like Helm differ from something like CDK or, one of these libraries to just provision something in ECS.
Yeah, at a super abstract level, CDK and it sounds like possibly the Rails provisioner library, those are aimed at developers who you're writing your app, you realize, okay, this is going to be a service. And this service is going to have a container and it's going to need to run somewhere. I'm going to need to present this API to some other services. So as a developer, you're thinking through, all this connectivity and this positioning of where this API is and that sort of thing. And you may not want to concern yourself with building scalability, building redundancy, building like all this other stuff. You just know that you want it, but you don't necessarily want to get into the nitty gritty of making it all happen. CDK and possibly this Rails provisioner can give you a sort of in app way of just pulling in all the best practices that it takes to run your container on the AWS infrastructure. Whether it's in our case with CDK, maybe it's EKS or even Kubernetes. Um, with the Rails provisioner or CDK, maybe it's ECS, maybe it's ECS using Fargate. So there's just all kinds of options for you to be able to sort of incorporate the infrastructure pieces that you're aware of, that you need, that you need, in with your application or possibly alongside your application to be able to specify that and then have those things pull in all the other dependencies that it takes to make that happen. So you might say, I want this to run on Fargate and be load balanced. And from that expands to let's build an ECS cluster in a VPC and have it, have a certain IAM role to execute, and let's scale it a certain way and monitor it a certain way and send logs, log aggregate a certain way, and so on and so forth that you don't have to necessarily specify. So that's really what that's all about.
Yeah, and I just to add, so because the topic of this week is EKS, and it feels like that tool is more for ECS. And I just want to add one thing that check out on GitHub. I'll actually put a link in the chat for the ECS CLI v2, where it's going to be able to do a lot of those predefined patterns that I saw in the Rails provisioner. Kind of declare what you want as YAML, or do it via the command line, and the ECS CLI v2 can build CI/CD pipelines, do all the opinionated things that Brent was mentioning, but handle that for you. So you, as a developer, you just focus on your app, your code, your container. That's it. So,
Exactly.
and that there was one other question about, it's good. Good. I
Yeah, yeah. Keep
honestly,
them coming.
yeah, I'd rather do this than um, than the content. I love the Q&A. I'm just kidding. So question was, what are the differences between EKS and Elastic Beanstalk?
Good question. Okay, so Elastic Beanstalk is also a good service. But if you think about it, Elastic Beanstalk is all about the developer experience first. and going from running your application locally potentially to running it in the cloud. And the way you get there and where you arrive is going to be quite a bit different than Kubernetes or EKS. So it's, I don't want to say single app focused, but it's almost single app focused. So you're able to like have your app running and then do a deploy and have your app running in the cloud. But what happens when you have a second app and a third app and a fourth and a fifth and so on? You're having to sort of go through those same motions, over and over and over again. With Kubernetes, in fact, when we dive into Helm, you're going to see we're actually going to provision and deploy 3 microservices together at the same time. Um, and so those are going to be happening from 3 different code bases, but they're all going to go out as one unified project. So it gives you a little bit more flexibility. Think of it as being the sort of advanced use case. So, when you're looking at a settings screen and they have the button show me the advanced options, that's when you're going from Beanstalk to EKS. You're going to a set of options that is wildly advanced and can give you all kinds of flexibility to do whatever it is you're trying to do. So that said, another difference is when you're running containers on Beanstalk, we're not really focused on fitting a bunch of containers onto a few instances, and we don't have to be focused on that with EKS, but we can be. So if you're trying to keep costs down, if that's your primary motivation, then EKS can actually help you by allowing you to run in a very dense manner. Um, Whereas Beanstalk, on the other hand, is going to be very linear growth. More apps, more instances, more cost. And some people aren't focused on cost, so that workflow might work great for them. So it's really about what is your motivation and what is going to work best for you, and then that's how one way you can decide what service you should take a look at. But again, this week we're focused on EKS, so we should definitely dive in and let's take a look at how do we use Helm. So yesterday we deployed our example microservices. And just to refresh your memory, I'm talking about the services that give us this functionality. So this is an example. It's barely more sophisticated than Hello World. But what it is, it's comprised of a front end application and then 2 back end applications. One is Node.js, the green one, and one is Crystal Lang, the orange one. These are brought up and communicated with internally in the cluster only using cluster IP. So the front end can talk directly to those using cluster IP. And then we can send traffic into the front end, into the cluster using a load balancer. So the type of service that we provision for the front end is typed load balancer. And we went through all of that yesterday. Definitely check out our video from yesterday if you want to catch up on that. But today, what we should look at is the files that we used yesterday. Those had some hard coded values in them and stuff like that. What if you wanted to template those? If you start to, if you're in dev mode, hard code, yeah, that's great. No big deal. But once you start to take that file, that declaration of how this service should be deployed or how the service should be reached, and you start to try and apply it into different environments, what you'll realize is some of those hard codes don't really translate well. I don't always want 3 copies of a service. I might only want one in dev, but 3 in production. So, how can I template that kind of information? And Helm can help us here. So, Helm has, I think of it as having 2 major functions. One, it's a package manager. So just like with Linux, you might use Yum or apt, or I don't know if anything's replaced any of those yet, DNF and something that may have replaced apt, who knows. Anyway, just like they have package managers where you can install things that are community provided, Helm is a package manager. So I can use it to install things that are community provided. But the second function that it has is it gives us the ability to template. So we can actually, in effect, build our own packages that we provide to our own cluster, and we can manage those, perhaps using an internal Git repo. So, and you can have a mixture of this stuff. You can have some community installed packages that use Helm, and then some that are packages that you created yourself. So, in this chapter, we're going to take a look at using Helm, and we're going to do both of those things. Cool. All right, so let's dive in. I see there was a question about Spinnaker, and yeah, definitely Adam's right on the money. Spinnaker is used for CI/CD, and it really, I would even say CD is its primary focus, whereas Helm is really just a packaging mechanism. It's a way to template and deploy. So I've not dug into Spinnaker with any kind of detail, but I can imagine a CD process might call Helm to do the actual delivery of the package. So that's something that that's kind of a similar relationship, but they're not really the same thing. Cool. Okay, so Helm. So the terminology for Helm, the main one that you'll want to be familiar with is what you're working with. With Yum, you're working with a package. With Helm, you're working with a chart. So a Helm chart is the unit that we package and that we apply to our cluster. So we're going to start off just installing Helm. And I don't know if you remember, I'm using Cloud9. So here's my Cloud9 environment. Um, and let's just check which Helm. Don't have Helm installed right now. So let's just install it. If you're at all familiar, even just loosely familiar with Helm's history, that you know that there was a major release a few months ago to Helm 3. And one of the differences, in fact, probably the biggest difference, is prior to Helm 3, Helm 2, and earlier, there was a service that ran on your cluster called Tiller. And Tiller was basically an administrative service. So Helm would talk to Tiller, and Tiller would carry out all the actions on your cluster. And to be able to do that, Tiller had to have admin level permission. Well, over the course of getting to Helm 3, the folks at Helm basically removed the need to have Tiller. So now there's no longer an administrative service running on your cluster ahead of time, and instead it just uses your administrative actions. So I have Helm installed. I just used their script to install it, patched it passed it to Bash, and that downloaded and installed Helm into user local bin. And now I can see Helm version. I have 324 installed. Now, without any more, there's really nothing I can do because now what Helm needs is to be able to find package repositories. So unless I've written my own package, it's not going to find any package repositories out there on the internet until I tell it where to find them. So there's a few places to find stuff. We're going to start off just looking at one of the main ones that is Kubernetes charts. So this is just probably, well, it's one of the main places to find Helm charts. So I've added that repo, and if I now search, by the way, when I added it, I named it stable. Let's see if I still can scroll back up to where that was. Here we go. Helm repo add, the name stable, and then the location for it. So now all of the charts that are found in this repository are prepended with the word stable. So stable slash whatever it is. And there's a lot of stuff here. I just did Helm search stable, and you can see there's a whole lot of stuff here to scroll through. And there's a ton of stuff that, I probably don't need, but maybe there's stuff that I'm looking for. So let me add on my bash completion just so I have that. And then let's actually explore just doing a basic install of NGINX. So I added my stable repo. If you ever want to refresh what its view of the repo to re-download any metadata for the repo and stuff like that, Helm repo update, just like Yum update, for example. So then what can we do? Well, let's actually search for NGINX. So Helm search repo NGINX, and I can see, sure enough, here's stable NGINX ingress, NGINX LDAP auth proxy, NGINX Lego, uh, G-Cloud endpoints. So basically what I'm finding are results where NGINX is anywhere. So as long as NGINX is somewhere in these results, then it's going to pop out and show me what I'm looking for. It's equivalent to doing Helm search grep NGINX. So how do I know what I want to install? Well, one thing you might consider is, how much do you trust the packager? Um, a lot of people have built trust in a packager called Bitnami. I don't know if any of you guys use Bitnami images, but they package up all kinds of stuff into all kinds of formats. One of the things that they package up is Helm charts. So if you think, I'm used to Bitnami, I think they're pretty smart, and I want to see what they have to offer. um, let's add the Bitnami repo to Helm. So we've done that. Helm repo add Bitnami, and then their chart URL. And if we want to see everything that they have to offer, we can search repo Bitnami, and you can see again lots and lots of stuff to look at, to potentially install. And this is all from a single source, Bitnami, and maybe, I trust them slightly more than the random stranger that may have contributed whatever other chart. So again, let's search for NGINX, see what we can find. So now we're getting our old results too, but we also have some Bitnami results in here, Bitnami NGINX and NGINX Ingress Controller. So we could consider installing those things rather than whatever the community provided NGINX was. And if we know, I'm looking specifically for Bitnami NGINX, search for exactly that, and you'll see just the results that match that come back. So this is really basic functionality search, but hopefully I've shown you a few examples that should be good enough to get you started. So how can we install Bitnami NGINX? Let's say that's the one I want. Install it for me. I have the solution collapsed right now. Uh, any guesses as to how we might install this?
I'm waiting in the chat. I think there's like a 20-second delay, so.
Nice. Oh, good. Well, I was actually asking if you might have any guesses.
Yeah. So my guess would be to run a Helm install. And
Totally.
Nginx chart name. Yep.
Yep. So yesterday I pointed out that cube control, the format of the command is cube control, verb, object, and then any more details, right? Um, Helm is exactly the same way. Helm, verb, object, and then any other details that we need to pass based on that information. So I've been doing Helm search. Search has been my verb thus far, but now I want to Helm install. So I'm going to Helm install my web server. Bitnami NGINX, and that's all it took. So I can see that now I've installed, and it I get some output. This is one of the cool things. Uh, I'll get to that question in a second.
Yeah, that's a
This
good
is one of
question.
the yeah. This is one of the things that I love about Helm is you can actually, as part of your chart, specify that there should be some output anytime someone installs something. And this is some helpful output. It may take a few minutes for the load balancer IP to be available, and I can watch with status with, and it gives me uh, a name or a command here that I can paste. So I'm sitting here watching. And of course, it is available right now, so there's really nothing more to watch. But here it is. Now, I also know that this is using ELB from from the EC2 console. That takes a little while to come up and go healthy. So we'll come back and we'll check in a couple more minutes. This should eventually come up and be healthy and show us the Nginx output. So there's a question: why would you use Nginx instead of Nginx Ingress? Well, what I'm trying to show is the equivalent of a hello world situation. So I want to show a web server or a web service, and I want to see the output that it provides. Nginx Ingress, on the other hand, would be something I would use to route traffic to some other service. So that's certainly a popular thing to do. But for this particular demo of installing a chart, I wanted to keep it simple. So, essentially what I've done is a hello world that it's still not out. We'll come back to that. Okay. By the way, there's some kind of advanced stuff here. Cube control get, and remember, cube control verb object. Well, notice in this command, a couple of things going on here. One, there's an abbreviation that you can use. You can actually type in the abbreviations, and as long as they are long enough to be unique, they can be as short as you want them to be. So PO, there's only one thing that's going to match that, and that's pod. There's only one object that we could be talking about. So you can do cube control get service, PO, and deploy, and get back the objects, service, pod, and deployment. So the second advanced kind of thing happening here is my target or my object can be multiple objects if I comma separate them. So that can be pretty handy too. If you're doing this though and you wanted like to watch, you can't watch if you're doing multiple objects. Okay, let's go back and check. Oh, there we go. There's our hello world. Welcome to Nginx. Okay. So we have our Helm chart installed. We have our Nginx service running. This could be any service, but basically it just shows us we installed something, a package from the internet, and it worked successfully.
So Brent, I have a question for you.
Yeah, go for it.
So, okay, this is cool. I can use, a Bitnami or some other upstream, but I, for my use case, I want to take that Nginx web service and I want to tweak it to make it my own. Can I make a Helm chart that's custom to how I would want a Helm chart to be deployed?
Yeah, absolutely. One common thing to do is to actually download Helm charts and tweak them and then install them locally. And in essence, that's what we'll be doing when we install our sample microservices. We'll be creating our own Helm chart, and we can tweak that however we want. But yeah, absolutely, that's something you could do. Just like if you think about a Docker image, like this has a Docker, this Helm chart deployed the Nginx Docker image. If I wanted to tweak that image, I can just start with from whatever that image name is, and then make all the changes below that I want and build that. So you can always use something, from the community as your starting point, and then just continue to iterate on it from there and make it something that'll be useful for you.
Yeah, makes sense.
Cool. All right, so let's move forward. Let's explore a little bit about what we have deployed here. Let's describe deployment my web server, and you can see some of the details, like the images, Docker IO, Bitnami, Nginx 119, blah blah blah. We're listing on port 80. Random host port gets assigned. Liveness and readiness probes are set. Mount point is set. There's a volume that's defined, and so on and so forth. So there's all kinds of details that we can dive into with the describe option. If you just want to see a list of any pods that are running, kube control get pods. And again, advanced level selector here, dash L, we are selecting all the pods that match, that have the label app Kubernetes IO name equals Nginx. So we could definitely, like, if we had more than one pod deployed, we would see the entire list here. Get service. We did this yesterday, but doing it again today. Dash O wide. That shows us a couple more columns, and it also won't truncate any of these really long columns that might get truncated on your output. And that's really about it. So let's check out, how would we uninstall. So if I Helm list, I can see all the Helm charts that I have installed right now. And you see my web server, that's what I named this Nginx deployment. And if I want to uninstall it, remember verb object, so Helm uninstall my web server, and now it's gone. And if I kube control get pods, see, there's no more resources found. And if I get service, that service still exists right now, but it'll eventually go away.
Yeah. Load balancer involved. There's a lot of things going on there.
Exactly. Yeah. And by the way, if we go, oh, I already closed the page, but if we were to go back to our page, it would no longer connect. Now I'm curious. Is it gone yet? There we go. Now it's gone. So that's a super basic example of Helm. How can we use Helm for our own microservices? So this is like just a level above. Let's build our own custom Helm charts. So a chart has a structure that is similar to what we find here. There's a directory, and inside that directory we have chart.yaml, where there's sort of some metadata, the name of the chart, the version, and stuff like that. There's a values.yaml where we might set up, the substitutions that we'll want to drop into our templates. Then there's templates and charts. Charts would be where we would stick any subcharts. Like this might be where, for my app deployment, if I wanted to use Nginx Ingress, I might have that as a dependency inside my charts folder. So for me to deploy this, it would first have to deploy Nginx Ingress. That's an example of subcharts. Okay, so there's a Helm create command. And if I run that, what it just did is it created this directory EKS demo, and it's laid out just like what I was showing you, where there's chart.yaml, values, and then a charts directory for subcharts, and a templates directory with all kinds of boilerplate that we can make use of. So let's see what we do next. So all this boilerplate stuff, you can certainly use it and fill it in if you want to. We're not going to. We're going to just use what we were using yesterday. So we're going to delete charts, values, and the templates directory. and kind of clean that stuff up. And then we're going to build our own stuff. So the first thing we'll build is our metadata file chart.yaml. And you can see what goes in here. It's pretty simple stuff. A name for our set of microservices, EKS demo, a description. If we wanted to version the releases or anything like that, we could do that here. But otherwise, it's just going to be kind of stock stuff. And then yesterday, as we deployed each of our microservices, we I don't know if you remember, but we applied deployment and service from each of our microservices, and then there was no, that was really it. It was deployment and service. So deployment described how to run our containers, and service described how to reach those containers, right? Well, what we're going to do here is we're going to copy the files that we deployed yesterday into our chart, and we're going to use those as our starting point. And this is very much how you might do it as a developer, because you might have just started off writing straight Kubernetes YAML, but then you realized, I really need to parameterize this. I really need to refactor it, template it, and that sort of thing. So Helm to the rescue, and just use what you've already written as your starting point. So one example of what you might want to parameterize might be the number of replicas. In dev, maybe you only need one replica. You're trying to save some space and run in as small a footprint as possible. But in production, you're probably never going to want one. You'll probably always want, more than one, so that you'll have some protection from any failures. So let's replace our hard-coded values with template directives. So in our templates, there's deployment and service. And if we open up deployment, let's start with the front end. Oh, I already did have it open. You know what? Let me close all these tabs so that I don't confuse myself, and then I'll reopen. There's front end. So replicas 1, I actually want to replace that with replicas and then the location where it can pull that value from. So I'm going to do this, then I'm going to yank, and then I'm going to go on to Node.js, find the same line, paste, delete, yank, save, crystal,
And
find the
going
line.
through this, it really reminds me of the days of doing this, on my, with the other companies I've worked for, and having to parameterize different values, and coming up with bash scripts to search and replace. I mean, this is a really nice way to not have to do that and let Helm take care of that for you. So it's clean.
Yeah, totally. I totally love using Helm when it comes to this kind of functionality. Okay, so I've replaced, the location where our replica's value is going to be pulled from. And then another thing that you might consider is replacing the image. So if we open up, let's see, if we open up the deployment, let's just replace the image with something that we'll pull from that same values file. So image, and again, delete what's here. I'm in the crystal file, so I'll set it to the crystal image. Yank, go to Node.js, paste, delete, Node.js.
And again, a great example here of maybe in your development environments, your latest image is always tagged dev, or maybe even latest. It's a development environment, you always want bleeding edge, but in production, obviously your version's not or shouldn't be latest, right? You should have a promoted artifact, and
Yeah,
that would be different. So
yeah, exactly. This is definitely something that will be parameterized pretty frequently. All right. So the last thing is to just create our values file. So how do you know what to deploy? How do you know what these values are going to be? Let's actually just create this file. And if we cat EKS demo values now, you'll see for replicas, I have 3. And let's go back and let's just look at the template real quick, what we have in here. Values is our values file. Dot replicas is sorry, leftmost key and the value, right? But here we have Node.js image and it's indented under Node.js, and then we have a value for that. So let's look at how that differs in our Node.js file. Values is the values file. Node.js is the leftmost key. Dot image is a subkey of that. And then we have, so we're going to substitute in the value for that. And then values.version, that's where we'll get whatever is in our values file version latest. So you see how we're able to template all of this, right? Looks like I need to save that. Everything else is saved. I'll go ahead and close these just to make sure. Perfect. I see Sans CC just keeps pasting emojis in the chat. I have no idea why. What's going on there?
I'm not sure. Is it like tipping the hat to us? I'm not sure.
Yeah,
I was trying to figure
I
that
have no
out
idea.
myself.
All right. Yes, thank you. Lots of beer or something. I don't know. All right, so let's install. This is another handy little thing to know. There's a dry run feature. There's also a dry run when you're running kube control. So let's just copy this. And what dry run does is it'll show us what would it do without without actually doing it. So this is all the YAML that we're about to kube control apply. And we can look and see, here's our values file up top. And then we can look and see, what are the values that are actually getting pasted in. So for example, here's a deployment for Crystal. And you can see there's the image that's getting pasted in. That was a combination of 2 different values. And then my replicas, instead of 1 that we had hard coded, you see that there's 3, right? So dry run. Didn't actually apply it, so that's not actually running. So let's go ahead and install. So Helm install, and then we give it a name. So this is going to be how we refer to this application or this deployment, this collection of applications, and then just the path to find the chart repo. So I can see environment EKS demo, that's where you find chart.yaml. And that's where you find values and stuff like that. So everything below that comprises the Helm chart, and I just installed it. So I think we're good to go. Remember our command kube control get service pods and deployments. Let's see what we have here. So remember yesterday we installed one copy of front end Node.js and Crystal, and then we scaled it up. And then we applied the services one at a time for each of those. But here you can see, here's my Crystal service. Remember yesterday we learned about cluster IP. So this is an internal only IP that's only reachable inside the cluster. And then same thing for Node.js, because these are backend services. They only need to be reachable inside the cluster by the front end. So we only do cluster IP for those. And then we have our front end service that's type load balancer. And that also does get a cluster IP, but it also then gets a load balancer provisioned. And then you can see we have 3 copies of each of our applications running. By the way, one other kind of cool advanced thing to take a look at here, if you ever look at a cluster and there's just a ton of pods running, and you're wondering like, are they all the same? Do they all look the same? Are they all the same version and all that stuff? Here's a little tip. So this is the human friendly name of the pod. Then there's a deployment ID, and then there's the pod ID. So the deployment ID, you notice, is the same for every copy of the pod in that whole deployment. So I can see that I have 3 copies of the exact same pod running. Now, elsewhere, maybe in a different namespace or just someone else on the cluster, they may have deployed a different version of Crystal, and it may be running under a different deployment ID. So I can see then that that's potentially a different version. It's not the same as this one right here. So just pay attention to that. I think that's a cool little way to easily spot like the progress of a deployment. If I were going to the next version of the Crystal service, I would see this is my version 1, my original version, and then I would see the new version getting rolled out, and it would have a different ID. Okay, so let's take a look at this load balancer, and let's see if our service is up yet.
And while we do that, I just wanted to let you know, Brent, that um, forgive me for pronouncing this wrong, but Yen Ray in the chat said, I just walked in and I feel like I've mastered YAML. So,
Hey, you need to have a good understanding of YAML to use Kubernetes. So I'm glad because master of YAML is going to be useful.
definitely. And there was a question that just came up. How would I know which one of those is the most recent? So this is on the topic of the deployments
Yeah.
here.
So what I was showing you is just a quick tip to spot, potential differences. If you wanted to dive in and just look at, all kinds of details, you can do kube control describe and then paste the full ID, and that's when you can sort of get in there and you can see, like what's the image tag that's being deployed, for example, or when was it started, and you could compare that potentially with the others. Really, it depends on what you're looking for. Are you looking for a specific image tag? Are you looking for the deployment time? Is most recent for you the one that's been running the least amount of time, or is it the one that has the build was after every other build available? Um, so it's describe can really help you dive in and get those details. You can also kube control describe deployments, and you can see just all the deployments all at the same time, and do your comparison that way if you want to. If you want a shorter output to look at, get, not really super helpful there. What does dash o wide do for us? From there, you could at least see the image tag. So that could be, if you're looking for image tag, then yeah, that'd be cool. SanCC says, "Can I create my own code in YAML?" I feel like by the time I'm done writing YAML, I have created my own code. Um, by the time I get it right and it actually works.
Yeah.
But no, as far as I know, there's no language that is just straight up YAML format. Um, I'm sure that some people feel like Ansible, for example, is some people think of it as a language, Ansible, and it's written basically in YAML. And you can do a lot with it, but ultimately you're just spawning other processes that are taking care of things for you in a step by step manner. So I wouldn't exactly call it a language, but you know, you could make that argument potentially. All right. So we tested our service. By the way, here's another little advanced tip here, dash O JSON path. So if we just run kube control get service ECS demo front end, then you see, there's a bunch of output, right? But if we then specify dash O JSON path, then what we're specifying here is show me status dot load balancer dot ingress, uh, that's an array, and then host name. So effectively what we're targeting is this output under external IP. And then I think we did, oh yeah, run echo just to get a line break there. So that is one programmatic way. If you ever wanted to like test, build this into some kind of test pipeline, you could programmatically get the I or the DNS name of the load balancer by doing this kind of query. And one more time, let's just see it running. This is live, by the way. This is on the internet. If anyone could type this address in fast enough to get it in their browser, they would be hitting the same containers that I'm hitting. So this isn't any kind of video or anything like that. So
And
pretty.
and Brent, so we are getting close to the top of the hour here, so uh,
Oh, nice.
just letting you know.
Yes, thank you. We don't have much left. Let me run through this real quick. What if you make a mistake? Um, So there's definitely a possibility as you're parameterizing stuff that you might mess something up. So for example, my Node.js image, what if I gave it the wrong name? So I just made that change. Let's do an roll out the next version of our chart here, upgrade workshop. So notice revision 2 just rolled out. And then let's get pods. So it's going to try and deploy a new Node.js pod. Notice, by the way, that deployment ID is different, but you see image pull back off. So my three have been up for 9 minutes. This one is hasn't even come up, and it's been 8 seconds. So it's obvious to me that it's newer. So what can I do about that? If I Helm status, you see revision 2 is currently deployed. And I know, the last version was working for me. So let's double check in our history. Version 1 is the last version. So let's roll back to version 1. Done. And now if we Helm history, now we have a third revision starting at 1955, and it's been deployed. And if I get pods, bam, we're back to fully healthy, nothing, image pullback off, no errors or anything like that. So you can roll back versions of a chart by doing Helm rollback. And then really, really basic, you want to get rid of something, Helm uninstall. And now that is gone. If I get pods, see how they're all terminating? And if I go over to my page here, it's no longer reloading. I can't get to it anymore. So everything is basically dying. So that's Helm. That's templating. That is an easier, better way to manage your YAML. So tell us what you think in the chat. Join us tomorrow. We're going to talk about health checks. We're going to bring up our application again, and we're going to disable some health checks, and we're going to see how the application responds.
Cool. And again, the recordings are made available after the stream. So we've been doing this since Monday. So if you missed any of those streams, please check the recordings and you can watch them from there. And then we are on Twitter, so please do give us a follow, as Brent mentioned. Our handles are below. So we as Brent said, we don't, we're not tweeting all the time. So when you see a tweet, it's going to be meaningful and hopefully something that you care about. So
Exactly. And I always try and include an animated GIF. So, you know,
it's always fun, and I felt like I've had to match that, and it's so much fun. I think I spent 10 minutes just trying to find. I'm sorry, I'm going to call it GIF. I know it's GIF, but I just can't. I'm sorry, but I spend at least 10 minutes trying to find just the right one, and it's. I think that's the hardest part of my job is figuring out which GIF I want to post on Twitter.
totally. Yeah, you only get one chance to get that right.
Exactly.
So it's awesome. All
Anyway,
right. We'll see everyone tomorrow. And until then, happy helming.
thanks so much.